A particle moves with a constant theta dot in a cardioid curve r equals 3 uh, open bracket 1 plus cosine theta. Find the radial and transverse components of the velocity and acceleration at any time. Remember that the first thing we have to do is to write the r equation, derive r dot, r double dot. Then we're going to be looking at the radial components, be it the velocity or the acceleration. So given that the velocity in the radial, well, in both directions is going to be given by now we look at the radial components, and the velocity will be equal to, for the radial components, r dot. R dot means minus 3 theta dot sine theta, as you're seeing here. If we draw the directions for the radial and the transverse, the components of the velocity will be given as shown here. It is r double, for the radial it's r double dot minus r theta dot square. And if we substitute r double dot into this, we will put this is r double dot, by the way, this point. We substitute it down here, minus r, which is 3 plus 3 cosine theta multiplied by theta dot, gives me this. Theta dot square gives me this. So this is the radial acceleration given here. Now for the velocity in the transverse, it's basically the r theta dot, where r is 3 plus 3 cos theta. All I have to do is just multiply that by theta dot, and I will get the transverse. Now for the acceleration, again it's r theta double dot plus 2r dot theta dot. If I substitute the value of r in here, multiplied by theta double dot, I get this part, plus the 2r dot, which is this one, multiplied by theta dot, I get the values we're seeing here. And if I just clean up a bit, I'll end up with the final expression that you're seeing in time.